Hi class. Today we are going to work on formally evaluating arguments in practice. We're going to learn a specific way to test the validity of claims. So I am working with a document camera, apologies, but I don't really have a marker board at home. And it's funny, I have a really nice document camera, but I don't actually have a printer, so you will have to at least tolerate my bad handwriting a little bit here. So I'm not going to review a ton of what we talked about last time, but very briefly, remember first we determine if it's deductive or inductive. The difference between those is whether the inference is based on logical certainty, that is definition rather than cause and effect. But then next we evaluate the inference. And when we evaluate inference, the question is never are the premises true, but assuming all premises were true, would they support the conclusion? And what we're going to work on today is a way to test deductive inference. It is called the counterexample method. So recall from last video, one hallmark of validity is a valid argument is one that its form is always truth-preserving. And the counterexample method just tests that. As such, it lets us determine if an inference is valid or not. And so when we're dealing with the counterexample method, there's really just a few steps. Step one, remember this is testing the validity, which means that it's testing the inference rather than the content. As such, we want to isolate the inference. We want to isolate only the form of the argument because that's what we're evaluating. So how do we isolate the form of an argument? Good question. We get rid of all the content and keep only logically important words. And you might say, what are logically important words? Great question. Now, here's the total list. All, no, some, and, or, if then, either or, and not. There's a lot of difference between not. So don't drop your knots. So if I'm doing that here, I just go through it. Is all a logically important word? Of course it is. Is men? No. So I'm going to replace it. Is are? Yes. Is mortal? No. And so what I might do here, sorry, I'm trying to get the camera just right. I'm going to say that the form of premise 1 are all M are, careful, we already used M here, so instead of for mortal, I'll use O. So all M are O is the form of premise 1. Notice we went from something that is clearly true to something that is neither true nor false. It could be either, and that's exactly what we want because we're testing the inference, not the truth and falsity. Well, what about premise 2? Socrates is historically important, but not logically important. So I'm going to replace that with an S. Is a man, but wait a minute, we already used man. So I'm going to use M again here. Conclusion. So we could use a line to represent therefore. We could write the word therefore, or we can use 3 dots. Any of those means therefore. The inference is drawn. Therefore, Socrates is mortal. So step 1, if we're trying to determine, again, the validity of the argument, we isolate the inference or the form of the inference, and that is what I've done below. All M are O, S is M, therefore S is O. This is the form of the argument. The second step is to provide what are called substitution instances. What's a substitution instance? It's basically a replacement for the argument in which it's the same form, but all premises are clearly true. So I want something of this form that is clearly true. All M are O. What's a true statement of that form? Here's one I like to use. All dogs are mammals. So if I am providing a substitution instance of the argument, M is dogs and O is mammals. Now I need something of the form S is a dog. Well, I have my dog Bruiser in the room right now. So we'll say Bruiser is a dog. So that is to provide a substitution instance. Now go back to the definition of validity. The definition of valid is one such that the form is always truth-preserving. Translating that to what we just learned with the counterexample method, if this inference is valid, then every time we come up with true premises, it should also spit out a true conclusion. So let's use the one I just did. All dogs are mammals, Bruiser is a dog, therefore Bruiser is a mammal. Is that true? Yes. And so this substitution instance effectively passes the test. In a valid argument, you will never find true premises and a false conclusion. In an invalid argument, you will find true premises and a false conclusion. When you do so, that is, if you provide a version of the argument that's a substitution instance, i.e. all true premises, with a false conclusion, that's called a counterexample. And, well, let's just pause there. So again, this is the form of the argument. Whoops. A substitution instance is an argument of this form with all true premises. A counterexample is a substitution instance, that is an argument of this form with true premises, with a false conclusion. Now, what does that mean? Tying it to validity, if we find a single counterexample, we know the argument is invalid. So notice if when I plug in true premises and it spits out a false conclusion, one and done. As soon as I find one counterexample method, I know one's counterexample, I know the argument cannot be valid. However, suppose I try one and it comes up with a true conclusion. Does that prove the argument is valid? No. Why not? Because the claim to validity is the claim that there are no counterexamples. So try a couple. Keep working at it until you feel comfortable. So here's a couple more substitution instances. All students enrolled in my class are enrolled at Kent State University. Vanessa is enrolled in my class. That's a substitution instance of this form, true premises. Is it true that Vanessa is enrolled at the university? Yes, she is. So, no false conclusion. All squares are rectangles. This thing over here is a square, therefore it's a rectangle. On and on and on. This one is valid. You will never find, what that means is you will never find a case where this is true and this is true, but this is false. It will not happen. It cannot happen. And if you get into, say, the logic classes, you can actually prove why it's valid. The counterexample method is somewhat of a gets and check, but it's good enough for our purposes. So if I was evaluating this argument, first of all, remember I told you it's the job of the sciences to tell us whether most premises are true. So if you saw something like this on the exam, you'd just see a T here, say, treat that premise as true. A T here, treat this premise as true. So to do the whole evaluation, is this deductive or inductive? It's deductive because the conclusion's just supposed to follow from the definition of all, no, some. And so we write that. Get in the habit of writing three things. Deductive. Valid or invalid. We just proved beyond a shadow of a doubt, well, not beyond a shadow of a doubt, but we've just proved using the counterexample method that it is valid. So we have answered question 3 on our chart. And so now, only if we've determined the deductive argument is valid do we go to the final evaluation of the argument, which is it sound or unsound? If we already know that it's valid, we simply ask, are all premises true? And don't get creative on me. The instructions on the exam will say, use the truth values I provide. So, are all premises assigned to T? Yes. And so the third part of that evaluation, sound. That was a lot, and don't worry, we're going to practice, both on this video and in the chat. So I'm going to give you another argument now. All squares are rectangles. All squares are trapezoids. Therefore, all rectangles are trapezoids. For you geometers in the room, that's true. That's true. And also the conclusion is true, by the way. Having said that, we must be careful because, as we saw in a few videos, just because something has a true conclusion, that does not mean it's a good inference. So, if I gave you this argument on an exam, you would need to evaluate it. You already know it's an argument because I told you that. So we first ask, is this argument deductive or inductive? Notice it's in some ways looks a lot like the argument we just did. And the reason why is this is another categorical syllogism, which means, like all other categorical syllogisms, it is deductive. It's supposed to follow just from the meaning of all know some. So once it's deductive, we always check the inference first. Is it valid or invalid? We never guess. We certainly don't look at the conclusion. We look at the inference. So we have to use the counterexample method, which you can only use for deductive arguments. We isolate the form of the argument, keeping only logically important words. How do we do that? Same as before. All is logically important. Squares is not, so I'm just going to replace it with an S. Are rectangles. So all S are R. As long as you can do this, just make sure you stay consistent. If S is squares in premise 1, S has to be squares in premise 2. All S are T is the second premise. Conclusion, all R are T. Just staying consistent. If it's rectangles here, it has to be there. That is the form of the argument. We have done what we're supposed to. We translated it into something that is neither true nor false. And we're going to test this inference. If this inference is valid, then we should find no counterexamples. What does that mean? Every time we plug in a substitution instance, i.e., we plug in true premises into this form, it spits out a true conclusion. Does it? Let's check. All humans are mammals. That's obviously true. In that case, S is humans, R is mammals. All humans are bipeds. Another clearly true, where S is still humans. But wait a minute. All humans are mammals, all humans are bipeds. From that, does it follow that all mammals are bipeds? It does not. My dog is not a biped, which means when S is humans, when R, you don't really need to write this out, is mammals, and when T is bipeds, it produces a counterexample because it makes premise 1 clearly and obviously true, premise 2 clearly and obviously true, and yet the conclusion clearly and obviously false. That is what we call a counterexample, which means we have proven beyond a shadow of a doubt that that argument is invalid. What does that mean? Going back to the original argument, yes, this is true, yes, this is true, but the fact that these are true has nothing to do with this. These two provide zero support for the conclusion. So even though the premises are true, they give you absolutely no reason whatsoever to accept the conclusion, which means that the argument has failed. The argument cannot persuade you to the conclusion, which makes it a failure as an argument. And for that reason, as soon as you write invalid, remember you're supposed to write unsound. Because for an argument to be good, that is, for a deductively sound argument, it has to do two things well. It has to have true premises and make a good inference from those premises. In this case, this argument is no different than saying Mickey's wearing a blue shirt, therefore a square has four sides. They're nothing to do with each other, even though they happen to be true. So this argument gives you no reason to accept the conclusion, hence unsound. Make sure you write all three of them. By the way, if doing this seems a little daunting, the key is to not get creative. Pretty much every premise should look like one of the following. All A or B, no A or B, some A or B, if A then B, A, B, A or B, either A or B. That is pretty much the total list with not sprinkled in where they're relevant. So you could put a not there, or there, or there, or there, etc. So that's what we do in terms of don't get creative on me. That's what your premises should look like, especially in this level. So let's try one more that is obviously deductive, that we have to do the counterexample method on, and then I'll give you some arguments. Approximate difficulty of the exam might be deductive or inductive. So how about this? If I am in Beijing, oh, sorry, the camera autofocuses, so I'll just write this first and then let it focus. If I am in Beijing, then I am in China. I am not in China. Therefore, I am not in Beijing. All right, there's the autofocus, and of course, this premise is true, this premise is true. So this is an example of a hypothetical. Remember the difference between deduction and induction is a distinction in the inference, and the question is whether the inference is just supposed to follow based on definitions or cause and effect and facts about the world. Notice, am I doing geography here? No, I'm saying that it follows from the definition of if-then. That's why it's a deductive argument, because whether you know anything about geography or not doesn't tell you if this is a good inference. Or I should say, even if you don't know anything about geography, you can tell about whether this is a good inference based on the form. So let's check. As mentioned, this is deductive because it is a hypothetical. Don't get creative on me. First premise is just going to be if B, then C. Sometimes the then is implied, by the way, and you have to fill it in. If B, then C. That's how premise 1 is symbolized, but careful. Make sure to articulate what those stand for. What does B stand for? It doesn't stand for Beijing. It stands for I am in Beijing. Similarly, C doesn't stand for China. It stands for I am in China. So, this helps us with premise 2. Premise 2 says, I am not in China. So this one would be abbreviated, careful, not C. Not is very important. Don't drop your not. Conclusion, I am not in Beijing. Not B. That is the argument. So that's a counterexample method step 1 for a hypothetical. So now we check for validity. We need some if A then B's that are true. Notice it might just help you to keep a rolling stock of obviously true premises of the various forms I just gave on the last page. Here's one I like. If you're in Indiana, you're in the US. That's obviously true. If I'm not in the US, would it follow that I'm not in Indiana? Yeah, it seems to. So that substitution instance spit out a true conclusion. Let's keep checking. If something is human, then it is a biped. My dog is not a biped. That's obviously true. Does it follow that my dog's not a human? Yeah, it seems to. If something is a rectangle, then it is a trapezoid. This pen is not a trapezoid. Does it follow that it's not rectangular? Yeah, it seems to. This one is in fact valid. And so now, once more, we just go back and say, are all premises true? In this case, yes. Don't just assume that. So remember the Obama space alien example. That one was valid but unsound. For the record, order matters. If I change the order here, I actually come up with an invalid argument. So instead, imagine I switch the premises and conclusion. So premise 1 stays the same. If B, then C. Not B, therefore not C. This form is invalid. I will leave it to you, but see if you can come up with a counterexample that shows that that's invalid. What should you be looking for? Something that clearly makes the premise true, clearly makes the second premise true, but clearly makes the conclusion false. If you want to pause it here and think of one, go for it. But notice you could use the one I already gave. If I'm in Indiana, I'm in the US. That's clearly true. I'm not in Indiana. Obviously true. I'm in Ohio. Does it follow that I'm not in the US? No, I'm still in the US. So this form is invalid. So order matters, as do the nots. All right, let's do a couple more arguments. There's going to be a lot more practice. So we're going to practice a few together, but let me tell you your other sources of practice first. First of all, notice there's that last document in on the logic stuff that is a practice quiz. I just give a bunch of arguments that are about the level of difficulty you might run into in this exam. And after I've given those, I actually explain what the answer is and why. So see if you can do those. And then, of course, we're going to keep working on them in the discussion boards. Even if you have your full credit for the discussion already, if this is something you're having trouble with, it's really important for the exam. And so I encourage you to make very sure to make use of the discussion board, even if you don't need the points and you still need the practice. So here's an argument. There was a blizzard today. That's false. Therefore, the picnic tomorrow will be canceled. All right, and it's auto-focusing, I can hear. So, deductive or inductive? This is the first one. I haven't told you which it is right away. So what we need to ask ourselves is, how is the conclusion supposed to follow? Is it supposed to follow based on definition and form? Or is it supposed to follow based on cause and effect and stuff about the world and the sciences? In this case, it's supposed to follow about cause and effect. Right, we're doing meteorology here. So, this is in fact an inductive argument. Cool. Now, we ask about the inference. So first of all, can we use the counterexample method here? The answer is no. Remember, the counterexample method only works for deductive arguments. Because deductive arguments, the form is always truth-preserving. In inductive arguments, the form is usually truth-preserving. And so we cannot use the counterexample method here. There are much more formal ways to evaluate inductive arguments, but what I mentioned, remember, you can just ask your inference question. Assuming it were true that there were a blizzard today, would you bet that a picnic tomorrow would be canceled? And the answer is yes. That makes it likely that there will be no picnic tomorrow, and that's enough to call the argument strong. It means it has a good inference. And only when it's strong do we bother to ask the last question, is it a good argument overall? That is it cogent? Since a cogent argument is a strong argument with all true premises, once we've determined it's strong, we just need to ask, are all premises true? Nope. And so it is uncogent, which means even though it makes a good inference, this argument fails and therefore does not give you adequate reason to accept the conclusion. So that's about the difficulty of one you'd have on the exam. We're going to do 2 more and then call it a day. How about Mickey says this argument is valid. That's false. Therefore, this argument is valid. All right. First of all, you might now realize why I always say this guy when I say Mickey. If ever I use that in an argument example, I'm specifically referring to myself rather than just anyone who happens to be named Mickey. So, deductive or inductive? Is this saying something that we should accept a conclusion from the premises based on the world and the sciences, or is it from form and definition? Sadly, Mickey is not definitionally correct. So, this is an inductive argument. In fact, this is one of those inductive arguments we refer to as an argument from authority. Now, notice that in the premise, it doesn't say anything about whether Mickey is an authority in logic or not. That's okay if it's common knowledge. So, do you know I'm an authority on logic? I hope so, since you are taking a course with me. I do have a PhD. So, given that it's common knowledge, it doesn't need to be included in the premise. So now we simply need to ask, assuming Mickey did tell you an argument was valid, would that make it likely that that argument is valid? Would you put money on it? Is it more than 50% likely? Et cetera, et cetera. And the answer is yes. So this argument is also strong. And the last step, are all premises true? No, this one is uncogent as well. You know what, let's do 2 more instead of 1 more. Let's see. No dogs or bats. That's certainly true. Some dogs are squirrels. That's false. Conclusion. Sorry, that's supposed to be are not. Yeah, that's fine. Some dogs are squirrels. Therefore, some bats are not squirrels. All right, deductive or inductive. This is another all no sum. It's just supposed to follow from the definition of all no sum. Makes it deductive, which means we don't just guess its validity, we check. We do the counterexample method. I'm going to do a little quickly. Feel free to pause the video now if you want to see if you can generate it on your own first. Try to get the form of this argument. Should be no D are B. Some D are S. Conclusion, some B are not S. So now, we simply need to provide some substitution instances, some clearly true no statements. No students in this class are professors. Some students in this class are self-identified as females. Therefore, some professors are not self-identified as females. True premise, true conclusion. Let's check a few more, though. No dogs are birds. Some dogs are schnauzers. Therefore, some birds are not schnauzers. That one seems to work true, too. Should we stop? I always say keep going until you're kind of comfortable seeing the logic. Because notice if we change the order a little bit, we actually can run into an issue. So no schnauzer, no dogs are birds. Oh, that's one I already did. Sorry. This one is, in fact, you know what? Let's leave that for you. This one is invalid. And if this one is one that's actually really hard to come up with a counterexample for, but they are there. And so it's actually a really good exercise to do on your own because that kind of enforces why you need to keep trying until you're comfortable with it. So again, if you want to pause here until you could come up with a counterexample, that's fine. All right, so once we've determined it's invalid, we can just automatically write unsound. By the way, if it did happen to turn out that it was valid, it would still be unsound because even though one premise is true, the question for soundness is, are all premises true? So it's going to be unsound either way, but just watch to make sure you're asking, are all premises true when you're checking soundness and cogency. All right. let's see here. So we've looked at let's do one more argument because I want you to see what things kind of look like. Sam gives good reasons to think we should raise minimum wage. Raise minimum wage. And that's true. But Sam makes minimum wage. Therefore, we should discount his arguments. All right. This is inductive. Sorry, let me let the autofocus work. This is inductive. We're clearly talking about cause and effect in the world rather than definition. Strong or weak. This is, we can approach this a few different ways, but what we should be doing first and foremost is asking our inference question. Assuming it were true that Sam gives good reasons to think that we should raise minimum wage, and assuming it were true that Sam did indeed make minimum wage, would it follow that we should reject their arguments? The answer is no, because why in the world would we? This is a weak argument, and here's the reason why. These two premises have nothing to do with the conclusion. They give no support at all. And this is actually a fallacy from that list of the argument summary. It's one of the against the person arguments. Well, you dismiss the argument because of the person who's saying it. That is almost never appropriate, and so since it's weak, it's automatically uncogent. So sometimes inductive arguments are weak because the premises have nothing to do with the conclusion. However, there's another thing we can do as well. We could say something like, the Browns lost for the last 28 years. Let's just call that true. I think that's pretty obviously true. And then we say, therefore, the Browns will lose this year. Waiting for the autofocus. So here's an interesting argument. It's inductive because it's a prediction. It's about cause and effect. It's saying the future will resemble the past. But here's a question. How strong is that argument? Assuming it were true that the Browns have lost a lot, does that follow that the Browns will lose this year? No, it doesn't, because there's a lot of other factors involved. So this argument is weak for a different reason. The distinction I'm trying to draw out between this argument and the last one is there's two ways an argument could be weak, basically. In the previous argument, the premises simply had nothing to do with the conclusion. As such, they're just irrelevant. However, this one gives a premise that is relevant, but it's not enough. So it gives me some reason to accept the conclusion, but not enough to. Sorry, give me some reason to accept the conclusion, but not enough to persuade me. And so remember, weak arguments can be scaling. If the premises make the conclusion 20% likely, then that's enough. Sorry, that's not enough. Oh, And so it's only when the premises make the conclusion likely that we accept them. So an argument whose premises make the conclusion 49% likely is a weak argument, but so is one whose premises make the conclusion 0% likely. And so just the ones that are like this, where the premises have something to do with the conclusion but not enough, those are a little trickier. And the way that can happen, those are what are listed in the fallacies of weak induction on the handout. The ones that the premises have nothing to do with the conclusion are the ones that are the fallacies of relevance. So I have gone way long here, but I hope it was helpful. And next after this, we are going to take what we've learned and we're going to start looking at the apology. So let me say a few words about the apology. It's called Plato's apology, but what that actually means, Plato's apology. Both of those words are wrong. It's actually Socrates' apologia, which means defense. So in the next reading, we are getting basically half a court transcript. Plato was the one who wrote it down, but we are looking at the trial of Socrates. This is a historical case that happened, and multiple people wrote down Socrates' defense, so we know this is very accurate of what he said. But roughly speaking, he was put on trial for doing philosophy. And so in order to defend himself, he has to convince the jury that philosophy is something we should do and is worthwhile. And so in an important sense, that's what's going on in the apology. And we read it for three good reasons. First of all, it's very important to Unit 1 in just convincing us we should be doing philosophy. Second part, there's some really nice arguments to be pulled out of the text. And we will be working on those in the second apology video, so make sure to do that one with your textbook in front of you. And then the third reason is, how to put it? So it introduces us to some very important kind of big picture philosophy stuff. Socrates was known as the father of Western philosophy. And he was important enough that all the philosophers before him were simply known as the pre-Socratics. He kind of turned philosophy towards what we look at now. So we get some of his ideas, so it's also a very important text, kind of historically. Otherwise, go read it and then watch the apology videos. Sorry to go a little long.